when you get the side lengths, I'm going to put up a extension way to find the area of this triangle that you can do if you find the other way easier. So now you can have another way to find the area of the triangle. So that'll also give you the area of the triangle, just using sides. Pretty cool. So try it when you're done. Yeah, here on its formula. Always useful to have multiple tools. What do you think, Julia? Are you getting closer? Yeah. Okay. Oh yeah, if you want to put units, just so you can create a unit square. Mm-hmm. Sure. Check if you're in degree modes.
Yeah, because I was actually in radio.
Yep. That's it. Julia, ready? Yeah. All right. Keep your space here. Okay, so Julia's going to help us out today. Ask her questions if you have any.
Okay, so first, in order to find the area, we have to know the sides. So first, then we're just going to do, we have to do 180 minus 107 minus 42 to find this area, which is then 31 degrees. And then so since we know that, and we know that this side is 12, then we have to do the sine of 107 over 12, because this is like the sine A over A. And then so I'm going to try to find the side H first. So it'd be sine 42 over H. So then that will make it, since we cross multiply, sine 107 H is equal to
And just click back down there on the pen.
sine 42. Oh god, this is really crooked. Okay. 12. So then, since this is a side with the exponent, we're going to divide sine of 107 on both sides, which then gives us h as 8.4.
Looks good.
Okay.
And you showed us the steps on this one, so then just tell us what K is.
Okay, so
Yeah.
then for K, I got 6.5.
You get 6.5 for K? Yeah. Alright, good.
Okay, so then since now we know all of the sides and all of the angles, we can really do anything
Mhm.
for the area. And so the area formula is half EC and then sine of A. I sort of just converted it, like, so it was easier for me, into the numbers that we're working with. So I did area is equal to 1/2 J K and then sine of H. So then plug that in and do 1/2 and then 12 since it's J.
Could you pause for 1 second? Could you circle for us what you did to the area of the triangle that you're taking these from, if it's unclear? Or no, on the triangle. Could you circle the numbers that you're
Oh.
like that?
So I'm going to use 12
Mhm.
as the J.
Mhm.
I can plug that from right there. So use that to switch it.
Yeah, easy fix. Hit this one. And then let's hit that one again. Time.
Okay. And then, so then the J is 12. And then we're using the K, which is 6.5. And then, since we're using sine of H, that'd be sine of 42. And then when you plug it all into your calculator, I got 26.09, which then turns into 26.1, and that is the area
Mhm.
of triangle JH.
There you go. Just don't forget your unit squared there on the bottom.
Oh yeah,
26.1 units squared.
is that times squared?
And you can just call it U squared, unit squared. Alright, and sounds like everybody else looking around, you got the same thing, so nice job. Thanks, Julia. And again, all you have to do is circle a side angle side, and those are the values you can work with for the area.
So how do you know which of the formulas to choose?
Oh, it doesn't matter. As long as I could have circled this side angle side, or I could have used this side angle side. Julia chose to use this side angle side. All of them will give you approximately the same area.
It's always a side angle.
Say it again.
It's always a side.
Yes, you will just circle a side angle side. It has to be in that order. Side angle side.
Because I got 26.2 for
Yeah,
that.
they'll be approximately around the same thing. Just like if you do this one right here.
That's the one I did.
Yeah, this will be approximate. It'll be approximate to this, it'll be approximate to this, and if you do 1/2 base times height, it'll be approximate to that. Okay? So nice job there, Julia. We have to do something that's going to be the most abstract, probably thing that we've done so far, which is something called an ambiguous case. And it goes like this before we start taking notes. If I give you an angle, A, and I give you a side that's adjacent to it, B, and I give you another side, A, if I give you this information, there's a possibility that you either A, get one triangle, or possibly this is too small and you can't bring it down to the base, so you have 0 triangles. Or it's possible that you have something that works nicely so that you can either have a triangle like this or a triangle like that, so you could have 2 triangles. And that's what's going to make today a little bit more complicated than usual, because we have separate cases. This is in Schoology, so I'm not going to, I think you should probably use those because it's a waste of time to have you copy it down. So I would use the notes that are in Schoology today. I just want to talk about the information. So how many of you have read up on this already? 1, some, 2, none. Is it very easy to understand? Well, I don't think so. You guys say maybe. Say it again. Hard to remember. You don't have to worry about remembering this. I'll give it to you, right? You just have to know how to use it. So let's practice that. But I wanted to get from you all is what you just said. It's not that easy. Right? It takes a little practice. So let's do this together. Here's the cases I was talking about. Perhaps angle A is acute. And I give you this side and I give you A. Well, if A is less than the height of the triangle, Everett, if you think A is less than the height of the triangle, can I make a triangle? How come?
Sides have to be longer than
This is the shortest distance. If this is shorter than the shortest distance, there's no way it's going to touch. If it's equal to h, can I make a triangle? Yeah, and it's going to make a right triangle. Because if this is the shortest distance, all right, it's going to be perpendicular to this line. That means it created a 90-degree angle. So it's going to form a right triangle. That's one possibility. There's also another case where you have one triangle. Well, maybe it's bigger or equal to B, the other side. Well, then you extend it out, and boom, you have a triangle. Because I didn't tell you anything about this length, did I? No. So it doesn't matter. I can extend this or shorten it to as far as I want. So I'd have one triangle here. Or maybe it's in between. It's sandwiched in between the height and the other side B. Well, that creates two triangles, and this is the most difficult case to work with. So that's the one we're going to focus our attention on today. That was if A is acute. Maybe A is right or obtuse. Well, here's some more tricky cases. If A is less than or equal to B, no triangle, not possible. Why? Because B is going to be the shortest distance, right? Here's a right angle. This is the shortest distance. So if this is equal to B, it goes right there. That's not a triangle. If it's less than that, it won't touch the side. It's not a triangle. If it's greater than B, you have one triangle. So only over here do you have a confusing case. All right? Do you understand why there are different scenarios? Okay. So you might want to summarize it with this little table here. Maybe. It might help you. I would do that. But I want to practice using this information. So let's do one or two together. Here's what we're going to do. Let's read it off. Bella, you read it off for us, will you?
A landscape architect is designing triangle flower beds. Determine the number of different triangles that he can form using the given measurements. Then solve the triangles. Round to the nearest center.
Okay, thank you. You want to draw a picture until you get used to these problems. So let's draw a picture. That's not easy to see. This is the side I'm not telling you anything about. Here is the angle I'm telling you something about. Just call it A to make it easy. I'm telling you that angle is 55 degrees. Already, I'm thinking back to that, what I was just looking at. This is an acute triangle, so I'm going to be looking in that part of my graphic organizer. This side, am I going to call this B or A? B. B is equal to 9 meters. A is equal to 6 meters. And now we want to say, what kind of triangles are possible? Maybe 1, maybe 0, maybe 2. Well, let's check. First thing you want to do in this type of problem is look at the height. Let's look at the height of this triangle. Height of this triangle. Drop the altitude. And now I have a triangle that looks like this. 55, height, and 9 meters. Well, I can find out what the height is pretty quick, right? Sine of 55 equals h over 9. Sine of 55 equals h over 9. Solve for h. 9 times sine of 55 equals h. You plug that into your calculator, tell me what that is.
The 7 point.
Right here.
No, but where does that set up?
Where does it come from? I'm trying to find the height, right? So make a perpendicular line, that's the altitude. That creates the right triangle. Here's the angle 55. Here's the opposite side, which is h, the height. And here is the hypotenuse, which is 9. Did I have this backwards? Nope, h over 9.
H is 7.37.
7.37? But Cora, did that answer your question? Yeah. Okay. So you said it's 7.37? I didn't verify with any other people.
Yeah.
Is that right? Yeah? Okay. Good. Now let's go back. We have A, we have B, and we have H. So let's go back to the other screen, and let's look at the information. Let me turn that off. It's annoying. I'm looking here or here? Here. Well, A doesn't equal H. Is A less than H? No? Are you sure? A is? Yeah. What was A?
6.
What was H?
7.37.
Okay, so I am here. No triangle possible. Right? So no flowers for that guy. Alright, no triangles. 0 triangles. And you should give reason. Why? Acute triangle. And you have that A is less than H. Okay? Or I should say acute angle A. Acute angle A. Alright, so that one was easy, right? There, that was nice. Well, now let's try one where we get 2. You try the setup, find the height, or find some way to compare A and B, and tell me how many triangles we're going to have. Maybe it's 1, maybe it's 0, maybe it's 2. You can actually already tell what it's going to be if you look back at that graphic organizer. Does anybody see what it's going to be already? Let's check.
Is B always the bottom side?
B is going to be adjacent to your angle. I think it's going to be 2. Let's see. No, I guess we do have to find H. Never mind. Okay, let's find H. Well, I think it's going to work out like this, right? H is going to be 9 times sine of 35. And what did you find out that was? 5.16. Okay. So the height is 5.16. If you look back at your graphic organizer, yep. You set it up like this. Right triangle, sine of this is height over 9, multiplied by 9, and you get that. Well, what you have right now is height is less than A, which is less than B, right? Yeah. So that tells you there are two triangles. And this is where it gets tricky. But it's okay, we'll get through it. This was the first step, find the height, so we can make our comparison. And now let's go to step 2 and 3 where we solve for these triangles. Okay. Well, one case is going to look like this. This is just how it's going to play out. One case is going to look like this. And one case is going to look like this. These are the two cases that we're going to have. Here's A. Here's A. Let's go ahead and label these so we don't get lost. 9 meters. 9 meters. 8 meters. Again, anytime you have two triangles with an acute, it's going to end up like this. 50, 35, 35. I would solve this one first. It's going to be easier to solve. Okay, well let's solve this. What am I going to use to solve this triangle? Yep.
What do you mean by
Solve means find all the missing pieces. You want to find all the missing pieces. We learned something yesterday that's applicable here. What is it? Okay, using that information, but it's called law of sines. Yep. So let's do the law of sines. Law of sines says that, I'm going to label these too. This one will be C. This one will be B. Law of sines says that sine of A over A equals sine of B over B. And let's fill in that information. Sine of A is sine of 35. Side A is 8. Sine of B, I don't know. Side B looks like 9. Cross multiply by that 9, or just cancel the 9 and multiply both sides by 9. And you'll get, I'm just going to write it right here and cross it out because I multiplied both sides by 9. Well, I have sine of B is 9 sine of 35 divided by 8. What do I have to do to both sides? I have to get rid of that sine, don't I? So I have to do sine inverse. Yep. Sine inverse both sides. Well, you want to do it to that whole piece. So I want you to look for a second. This is just one number. This whole piece right here is just one number. So you want to do sine inverse to this whole number. Sine inverse of 9 sine 35 all over 8. That's going to be equal to measure of angle B.
40.18.
You got 40.18?
Or 40.19.
40.19? Anybody else? Everybody should practice typing that in because there's a lot of syntax in there, and if you don't do it right.
Well, I just did like cross multiplying divides, so I got like 40.5.
I don't know what you'd be dividing though, because we need to definitely do sine inverse.
Well, I did like sine 35 times 9 divided by 8, and then I just did sine inverse.
Right. So your answer though, while it might be close, it's going to be a little bit less accurate than ours because you rounded twice and we're only rounding once. Yep. So what was it again? 40 point.
In the this is would it be sine multiplied by 8 also multiplied by b if you're doing cross multiplication?
we're not going to cross multiply. I should have said it more clearly. We want to cancel the 9. Get rid of the 9 by multiplying both sides by 9 because we want to isolate B.
Oh, okay,
Yeah.
okay.
So tell me the number again.
You do the inverse sign.
40.19.
From B, right?
40.19. Hold on 1 second there. I think it said round to the nearest 10. So 40.2. 40.2 degrees is measure of angle B. Now, what were you saying there, Karsten?
I was just like, so you do the sign inverse to get rid of the sign in front of B, right?
Yes.
So
That
you
got
just-
rid of our sign
To isolate B.
to isolate B.
Okay.
Yep.
Just make sure.
Good question. So you said this was 40.2. Well, then tell me what's C? Calculate C for me. Calculate C for me. 104.8. Thank you, Johanna. 104.8. You're going to solve the rest of that triangle, because what are you going to use to solve it? What you already know how to do? Law of sines. So you're going to finish that one, but I want to bring you over here now to the second triangle to help you out with that one. So you have all you need to solve that triangle, but now I want to bring you over to this one. So now we're in a new triangle. We're in a new triangle. We're coming over here. You didn't finish this job yet. You still need to. Well, let's look. All you have to do to find out this angle right here, this is still B. Okay, this is still measure of angle B. All you have to do is take the reference angle. What's the reference angle? Right, 180, subtract this, right? This is our reference angle, subtract it from 180, and boom, you're going to have B. All you have to do, each time, 180, subtract the B you just found. That's it. 180, subtract the B you just found. 40.2. So what is that? 130.8. Measure of angle B equals 139.8. Is that a pretty easy rule to remember? Yeah. Take the reference angle, subtract it from 180, and you have your new angle. That will give you the obtuse version. Yep. So this is the obtuse version. Good. Yep. 40.2. Oh, it said rounded to the nearest 10. Yes, this is going to be our reference angle. We want to turn it into an obtuse angle, so we're going to subtract it from 180, right, to get a coterminal, or not a coterminal angle. Is the language right? Anyways, regardless of the language, I'll work on that, but is this clear? Okay. All right, so now we have B, 35, B is 139.8, so what's C? Should be really small, right? What is it? 3.2? Eight point two? I got one person tell me 8.2. Angle C. Should have more people tell me. 5.2. Well, again, this goes back to triangles, 180 degrees. 180 minus 35 minus 139.8.
Where did the reference angle come from?
So again, this is just a rule I'm going to tell you to find this obtuse angle. You're just going to say, I want that same angle, but I want the obtuse version of it. Right? You can kind of think of it as coterminal. You just take 180, subtract off the 40.2, boom, you have it. Okay. So we found this one to be 5.2. Your job then is to finish off this triangle for me. Find C here, and tell me what it is, and I'll walk around and see if you have trouble.
Oh, like the length.
Yes, find me length of side C and length of side C. Maybe ask your classmates if you have some trouble. You already found it?
I think so.
Okay.
Or like our final answer should be like the right one.
You should make a triangle that's super clear to me with all the sides
Okay.
and angles.
For the first one,
Okay, that's good. Anybody else? Got a couple numbers here that I can verify.
So, yeah, so maybe it's sine inverse
So now we're using the law of sines to find that last side. Use the law of sines to find the last side.
just
An answer yet? An answer yet?
yeah. It's a parentheses, so if you do it after that, I don't know why someone calculated it.
So
Yeah, because it'll just
multiply
take
by
the, it'll take this, like the
All
sine
the
of
sides add up to 180, so you do 180 minus 30.
And also
I just know that.
multiply both sides by 9 to get rid of the 9. So we get that guy.
It took me a minute. I thought the other angle was
And divide both sides by the sides.
So for the obtuse one, you just subtract
You get a number
the
yet?
one.
Start working on it. You get a number yet? Yeah, that's an answer. 1.26, 1.3, and 13.5. Yep. So it looks like C was 13.5 for this one,
Yeah.
and it was 1.26, or if you round up, 1.3 for this one. Yep. C was, let me find out what that would be. So your answers will look a lot nicer than mine. Mine is on this crappy board, so wish I had a whiteboard. All right. Did we solve the triangle?
Only one.
Yeah, we did. We have 2, 3 sides. We have 3 angles. We solved them.
What was the measuring of the length of C?
For this one, it was 1.26. We rounded up to 1.3. For this one, it was 13.5. I think it must have been 13.46 or 13.5 something. Are we good on that? Okay. I'll take that. We still got 10 minutes, so we might as well practice one more, okay? Just to make sure we're good with this. So, I want you to try it at your tables for 6 minutes, and then I'll put the answers up here, but I want you to work together. Help somebody at your table who's struggling. Ask for help if you're struggling. Ask for help if you're struggling. All right? So you take note of the information that you have. Angle A is acute, B is less than A, so I check my reference sheet and see where I'm at when you check it. And let me hear it when you find out what we're at. How many? 1? Hearing people say 1. So our reference sheet tells us 1 triangle. Yeah. And see if you can solve it on your own. I'll put it up here, but see if you can solve it. Right. Yeah, or you can use this reference sheet too. have to worry about memorizing the reference sheet. And if you start seeing the algorithm that makes this work, right, you can just jump straight to it, and you don't have to go through the multiplication every time. If you can just see what happens. Like I can see that this is going to be sine inverse of,
G sine 20 over 50.
right. So if you can see that, then you can just write that down. But you have to write it down. Don't just write down an answer. This is going to give me the measure of angle B. Type that in your calculator. $10.82. Okay. It's an angle, so we're going to put degrees. Nearest 10, 10.8. That tells me angle C. $141.2 for angle C. Good. Okay.
C is 66.7.
You got 66.7?
I got 53.8.
Oh, so we have some disagreement there. I'm going to wait then.
Oh.
I got 66.9.
You got what?
66.9.
66.9.
It's rounded.
Rounded. Let's check.
I just used Pythagorean. Wait, never
Oh, you can't use
mind.
Pythagorean,
Yeah,
right?
never mind. Yeah.
Be careful.
Wait, you got 66.7?
Sine
Yeah,
of
that's right.
B was what? 10.8. Wait, what? Wrong thing. 141.2. So what did we say the answer is going to be? We come to agreement? Let's hear it. Say it loud, say it proud.
66.7.
60. I can't hear it.
66.7.
66.7. 66.7 looks right. 66.7. There you go. Nice.
Oh, that's it.
Nice. All right. If you're having trouble, right? I know this is a little bit abstract, but hopefully you're doing okay. Do you have any questions from the homework you want to go over? Like the word problem, 29, or anything? 29? Okay, sure. Let's do 29. Let's do that. Anybody want to do 29 for a presentation?
I can do it.
You want to do it? All right.
Oh,
You gonna write real nice for me?
I can try.
No, you're going to. Just write small. That's the key. Write small.
If we're doing math, if our math degree tomorrow is on this, I can do it.
Okay. You want to do it tomorrow?
Sure.
All right. I like it. Get it done early, right?
Yeah, and I actually understand this unit, so I want to.
Is there another one this week?
That's what I like to hear.
Is there another one this quarter? Is this from?
Yeah, this is our new quarter.
Oh, okay. Oh, what was this like?
66.
You guys get this one?
It was only
Or has a 6 now?
Something happened to you.
Mine?
Yeah. Well, that one's wrong.
30.
Just this.
You think you got time to do it here, Matthew?
I could. Is it fine if I jump a few steps?
Yeah.
Okay. Then I can.
Just talk us through it.
Okay.
All right. Matthew's gonna help you out, and he's got a short amount of time, so I like it quiet so I can hear him.
So we are given these two angles, which by doing 180 minus those two angles, you will get this equals 17. And then from there, you could use the law of sine, which will allow you to do, well, to get D, we're just gonna go up here, equals, if you simplify and go through the steps of law of sine, you'll eventually get this 10 over sine 38.
Oh, careful. I don't like that. Erase it. Not smooth enough. Make it small.
D equals 10 sine 38 over sine 17. And then once you simplify that, you get D is about 21.1 feet by using the law of sine.
There you go. So what's the key for that problem if you're having trouble with it? You said?
The law of sine.
Law of sines. Law of sines. All right. Nice job, Matthew. Thank you.